All right, so before we get started on this lesson, I just wanted to make you aware that I will not be at school this week. So I will have videos for each of the lessons just like this, and answer keys and everything will still be online for you. So looking at 715, the first question is a review question. It says solve the system. So currently the way it is set up is not set up for anything like substitution, elimination, or equal values, but since we have a u by itself right here with nothing in front of it, I'm going to try to do substitution by just moving this 10 to the other side. And then I get u equals 2v plus 10. And now that I have that, I can take this 2v plus 10 and plug it in for u into the first equation. So I'm going to do that. 5 times the quantity 2v plus 10, and then I'm going to write the rest of it, plus 6v equals 2, and then I'm going to solve for v. The first thing I'm going to do is distribute the 5. So I get 10v plus 50, because it's 5 times 2v is 10v, and then 5 times 10 is 50. And then I'm going to add 6v equals 2. So then once I've done that step, the goal is to combine like terms. So 10v and 6v are like terms. So I'm going to add them. So I get 16v plus 50 equals 2. And then I'm going to try to get the 16v alone, so then I can get v alone. So I'm going to take away 50 from both sides. So I get 16v equals negative 48, because 2 minus 50 is negative 48. And then I'm going to divide both sides by 16 to get v by itself. So v is going to equal negative 3. And then once I'm done with that, I'm going to take that and plug it into one of the equations. I think I'm just going to plug it into this one right here, but you could pick from the first, the second, or that third one right there. So u equals 2v plus 10. So v was negative 3. So u equals 2 times negative 3 plus 10. So then u equals negative 6 plus 10, because I did 2 times negative 3. And then u equals 4. So u is 4 and v is negative 3. Take some time to wrap that up if you need to. That should feel like review, but again, we should continue to practice this stuff because you will probably be tested on it at a later date. So then the next part says reviewing exponential. So we've been doing this for a while now, but the form is y equals a times b to the x power. A stands for the starting value or 0th term. You can think about it either way. And then b is the multiplier. So graph and values will increase if b is greater than 1. And we've talked about this with the graphs on that one first day where I showed you the graph of what it looked like. And then also we've been talking about it with the different situations with like the pennies and the carbon. And then graph and values will decrease if b is between 0 and 1. So now we're going to look at a couple of things here. It says 759 graph to equation. So we've been doing the other way around, and now we're going to look at it differently. It says use the clues provided in each graph below to find a possible corresponding equation in y equals a times b to the x power form. Assume that if the graph has an asymptote, it is located on the x-axis. What an asymptote is, just as a reminder, is where the graph cannot pass that. So looking at A, there is 2 points kind of like specifically given to us, and then it's got like some pluses on it. So let's start with just the point on the y-axis, which would be our starting value. So that's 0, 5, because it's not going anywhere on the x, and then it goes up to 5. And then to find that second point there, it adds 1 for the x value, and then it adds 2 for the y value. So plus 2 would be 7. But since we know that this has to be exponential, we're not thinking about it in terms of plus 2 every time. We were just doing that just to get that second point. So we really need to figure out what we multiply by, so then we can write our equation and get where we need to be. So I'm just going to write 3, 4 in here just to get the next couple points. And before I can get those, I do have to find my multiplier. So to do that, to go forward, we multiply, but to go backwards, we divide. And then again, we're also going backwards when we're writing our equation when we divide. So we do 7 divided by 5 because we're going backwards. So when we do that, you would get 1.4. You could leave it as the decimal, but I just decided to put it in as... you could leave it as a fraction, but I decided to put it as a decimal. So times 1.4. So I already have everything to write my equation, but I'm just going to pop in the rest of these numbers into this table. So I'll multiply 7 times 1.4 to get to the next number, which is, 1 second, sorry, I just picked up my calculator, 9.8. And then I take that number again and I multiply that by 1.4, which is 13.72. So now that I have all that, I can write my equation. I really only needed my starting value and my multiplier. So y equals the starting value times the multiplier to the x power. So it's actually not too bad to go from a graph to a table to then an equation. As long as you've got some points on there. So then going to the next one, the point that it starts with is actually further back at -1, not at 0 like this one was. We had points, but they never told us exactly what they were. So here we're going to start at -1, and then this next point that we have is at 0, and then I'm just going to write the rest of these on here just because that was how it would go in order. That is not something that you just be assumed to know. Really what you would really have to know are these 2 points. The other 2 are not as important, and these 2 points, because they were the ones that were specifically given on the graph. The rest of it is just kind of, oh, I decided to write those in because there was space and it was asked to fill in more. So then at -1, it hits at 120. And then at 0, it hits at 40. And I'm just reading the graph given the information that it tells me. It's telling me information differently than it told me in this graph. But this one, I'm really familiar with slopes, so I know how to do that. And then this one is just reading points correctly. Just remember, in a graph, you have the x and y. X is left and right. Maybe I shouldn't have written it there, sorry. And y is up, down. So then looking at this, I need to figure out what my multiplier is. So again, I'm going to do the 40 divided by 120. Just again, to think through this, multiplier is going forward to multiply to get to the next number, but to undo to figure out what that forward multiplication number is, you'd have to divide. And when you're doing that, you'd have to go backwards. Excuse me. So 40 divided by 120 is 1/3, and writing that as a decimal is 0.3 repeating, so I'm not going to do that. I know that it's kind of contradictory with what I wrote before, but it also kind of shows you that you can write it as a decimal fraction, it doesn't matter, but in this case it's a lot easier to write it as 1/3 instead of writing 0.3 repeating. So the next number was 40, and then 40 times 1/3, it's going to get a little ugly, is 13.3 repeating. It might be nicer to write it as a fraction. And then times 1/3 is 4.4 repeating. So then we're going to write our equation. We really only needed our starting amount and our multiplier. Be careful, you know that your starting amount is not literally the thing you start with on your table. It's the 0th term. So make sure you're using that. Y equals 40 times 1/3 to the x power. Then the next one is the same kind of process here. So we're going to write, the first point is at 0, 7. And then the next one, they go all the way up to 3. So I'm just going to write 1, 2, 3, and then write 56 for that one. So this one we've talked about skipping, but it's a little weird for students. So we're going to talk about it more and see how that changes. So going to this one, we would do 56 divided by 7. And that's going to be 8. But you don't multiply by 8 to get to the next number. You multiply by 8 to get all the way through. So how many times do we have to hop to get to that 56? We have to go 1, 2, 3. So I have to know what number, the same number, has to multiply every time to get to 56, but using that 8 as a total of them multiplied. So like 3 times 3 times 3 is 8, something like that. But obviously that's not the answer. So here it might be easier because it's a smaller number to find. Sometimes it's not. So the way you solve this is you take the root of that number based on how many jumps. So 1, 2, 3 jumps would be the third root. 2 jumps would be the square root, the second root. 4 jumps is the fourth root. So you need to put that in your calculator. So to take the third root of 8 would be 2. So I need to multiply by 2 because what happens is I get 2 times 2 times 2 is 8, and that's how much it jumped. So then to get my next number, I'm going to do 7 times 2 is 14, and then 14 times 2 is 28. And just to make sure that I'm getting the correct multiplier, I'm going to do 28 times 2 just to make sure it gets 56, and that does. So then my equation is y equals my starting value times my multiplier to the x power. Then the next one, I'll start with, it's kind of weird because there's only like 1 point on here, but then we definitely know we have to have 0. So I'm going to say 0, 1, 2, 3, 4, 5. And you really don't even have to go all the way down to that because it's kind of behaving the same way, if that makes sense. And we'll see that in just a second. So at 0, it's at 18. But then at 1, it's 18, 2, it's 18, 3, it's 18, and so on. So you could skip all the way down to 5 and not even make more places in your table. Or you could just, excuse me, or you could just put it in as like up here, just pop it in as 5 in here, however you want to do it. But the real goal here is to figure out the equation. So we know our 0 term is 18, and then times, sorry, I like to use dots, you don't have to, times, and we know our multiplier, it's kind of weird, but a multiplier is 1. So 1 to the x power, 1 to any power, if you need to check it, 1 to the second power, 1 to the third power, 1 to the fifth power, any power is 1. So then I kind of need to change this into y equals 18 times 1, because it's anything to, remember, 1 to any power is going to be 1. And then that just really just is y equals 18. So the reason why this is y equals 18 and it doesn't look like this is because it's a line. And these are those exponential curves. That's why they are coming out differently. It still gets you the equation you need. It just looks different because it is a different thing. It's a line. So then the next one, looking at this next one, I've got 2 points here. And I don't have 0, so I know I need to get 0 at some point because I've got to get that for my starting value. So I'm going to still write 0 in. And then I've got 1 is nothing on there, but 2 and then 3 is on there, so I can fill those in. 2 is 75, 3 is 375. So I need to find the 0 term, but before I can do that, I need to find the multiplier. So currently I know it multiplied by something to go forward, so I need to go backward and divide. I know the number that has to go on top is the later number in the list because I'm starting from where I am to where I was. So 375, sorry, if that sounded weird, don't use that. It's just kind of like another way to think about it because we've been talking about it in different ways. I'm trying to give you another way to remember it. So then 375 divided by 75 is 5. I don't have to do that weird, oops, sorry. I don't have to do this weird jumping thing here because I'm not skipping any numbers. I don't know if you remembered, we knew this number and this number So that's why I had like all that in between stuff I had to jump through, but here I don't have to do that. So I don't have to change anything. I already know what I'm multiplying by. So then then to go backwards, I'm going to do 75 divided by 5 is 15, and then 15 divided by 5 is 3, and I had to go that far back because I needed the 0 term. So then I've got my equation is y equals the 0 term, or the starting value, times the multiplier to the x power. So then this next one looks a little different because of the direction it's going. So we're going to say x0 is -8 for this first point, and then 1, oh, that's a little ugly, sorry. 1 is -16, and then I don't know what 2 and 3 are, but I'm just going to go forward. You could technically do 0, 1, and then like go backwards and do -1, -2, it doesn't matter. But again, I'm just going to write those in. So I already have my 0 term is -18, and now I just need my multiplier. So going forward, I know I multiply, but to go backwards, I need to divide. And again, I'm going from where I am to where I was to figure out what my multiplier was. So don't forget the negatives, because both those negatives will make you become positive. So you multiply by 2 to go forward. So then -16 times 2 is -32, and then -16 times 3 is -48. So then I know that my multiplier is 2, and then to the x power. So I know there are review problems on here, but for today we're going to skip those, and you can work on your homework in class, and you'll have a little bit of time.